It's a global staple, a cornerstone of food security for millions, and a powerhouse of industrial potential. From its humble beginnings in the soil, the cassava root embarks on an extraordinary journey. But this isn't a story about small-scale farming. This is a story of immense scale, precision engineering, and an unbelievable transformation. We're going inside a state-of-the-art mega factory to see how this unassuming root is turned into a pure, valuable commodity. High-quality cassava flour. You've seen the final product on store shelves, a key ingredient in everything from gluten-free bread to industrial thickeners. But you've never seen it made like this. Forget what you know about peeling by hand and drying in the sun. We're about to enter a world of automated systems, roaring machinery, and scientific precision, where thousands of tons of raw cassava become pristine white flour every single day. This is the full industrial workflow, a symphony of steel and steam where a muddy root is purified and reborn. The journey starts now. Chapter 1. The Arrival and the Race Against Time. The whole process kicks off not with a single root, but with a relentless wave. Every hour, massive trucks, heavy with their earthy cargo, rumble up to the factory gates. They come from huge, specialized farms where the industrial chain has already begun. The loads they carry are staggering, literal mountains of freshly harvested cassava roots, the lifeblood of this entire operation. As the trucks reverse into high-capacity intake bays, a deep hum fills the air. Hydraulic lifts groan under the immense weight, tilting the entire trailer. In a thunderous cascade, tons of cassava pour into enormous subterranean hoppers. The ground actually vibrates with the sheer volume of it all. This factory doesn't count its input in baskets or bags, but in metric tons per hour. Now, from the moment a root is pulled from the ground, a clock starts ticking, and it ticks fast. Cassava is highly perishable. Once harvested, it starts to deteriorate almost immediately. To get the highest quality flour, the entire journey, from this unloading bay to a sealed bag, has to be incredibly quick. This urgency dictates the design, speed, and relentless 24/7 operation of the whole facility. Any delay risks spoilage and a catastrophic loss in quality. There are no weekends here, no holidays, just the continuous flow. Before the roots even get inside, a crucial quality check happens. Inspectors grab samples from each delivery, looking for healthy, starch-rich roots. They check for size and firmness, rejecting any that are bruised or rotten. Only the best of the best get to move on. From the hoppers, a system of conveyors starts moving this river of cassava forward. The journey into the heart of the factory has begun, and the first stop is a brutal trial by water and friction. The cleaning section. Chapter 2. The cleansing gauntlet, turning a muddy root into a food grade. Ingredient is a violent yet precisely controlled process. The cassava, still caked in farm soil, enters a series of machines designed to strip away every last trace of the outside world. This isn't a gentle wash. It's an industrial-scale scrubbing. Stage 1. The dry sieve. First, the roots tumble into a massive, rotating cylindrical cage called a dry sieve. As this huge drum spins, the roots knock against each other, and the metal grate. The constant tumbling shakes loose dry soil, sand, leaves, and small stones. The sound is a rhythmic clatter, and in just a few moments, the roots emerge noticeably cleaner, but their dark, tough skin is still there. This is just a preliminary clean, designed to get the big stuff off and reduce the load on the next stage. Stage 2. The paddle washer. From the dry sieve, the cassava is plunged into the churning water of the paddle washing machine. This is where the deep cleaning really starts. It's a long trough of water where powerful, rotating paddles churn the cassava with incredible force. This machine has a brilliant dual function. The violent agitation scrubs away the rest of the dirt, while the abrasive action of the roots rubbing against each other starts to tear away the thin outer peel. High-pressure water jets are constantly spraying the roots, carrying away all the dislodged gunk. The water, once clean, quickly turns into a dark, muddy slurry that's drained and recycled. After several minutes in this aquatic vortex, the roots emerge looking completely different, pale and off-white. Stage 3. The peeling machine. The apex of automation. Traditionally, it would take hours of back-breaking work to peel each root by hand. This mega factory does it in seconds with an automated cassava peeler. The washed roots are fed into a machine that uses sand roller technology. Inside, the cassava is tumbled against rotating rollers coated in a material like industrial-grade sandpaper. As the roots are forced against these spinning, abrasive rollers, the remaining layers of peel are literally sanded right off. The process is aggressive and loud, a continuous, high-pitched grinding sound. A constant spray of water cleans the roots and keeps the abrasive surfaces from getting clogged. The genius here is its efficiency. It's calibrated to remove the peel while losing as little of the valuable white, starchy flesh as possible. This one stage is a huge leap from traditional methods, saving countless hours of labor and dramatically boosting the factory's output. The roots that exit are almost unrecognizable. They're now smooth, white cylinders of pure starch, ready to have their value unlocked. Chapter 3. The heart of transformation, pulverization and purification. Now that they're stripped bare, the pristine white roots are ready to be completely broken down. The goal here is to rupture the root's cellular structure, releasing the millions of tiny starch granules locked inside. This is done with immense mechanical force, turning solid roots into a liquid slurry. Stage 1. The rasper, unleashing the starch. A conveyor carries the peeled roots to the maw of the cassava rasper, the true heart of the production process. Inside its heavy steel housing, a large drum studded with hundreds of sharp, saw-toothed blades rotates at an incredibly high speed. As the roots are fed in, they meet this furiously spinning wall of blades. The impact is instantaneous and total. The roots aren't just chopped or sliced. They are completely pulverized into a fine, wet pulp in a fraction of a second. The high-pitched, roaring whine of the machine is a testament to the power it takes to do this. This violent action is critical for breaking open the plant's cell walls to get the maximum amount of starch. What comes out is now cassava slurry, a thick, white, porridge-like mixture of starch, fiber, and water. Stage 2. The unseen enemy, desanding. From the rasper, the slurry is pumped to a machine that handles a problem you'd probably never think of. Sand. Even with all that washing, microscopic bits of grit can remain. If left in, this would give the flour a gritty, unpleasant texture. To fight this, the slurry enters a desanding cyclone. This clever device uses physics to do its job. The slurry is pumped into a cone-shaped chamber, creating a vortex. As it spirals at high speed, centrifugal force flings the heavier sand particles to the outside walls. They slide down and are collected at the bottom. Meanwhile, the lighter, purified slurry is drawn up through a separate outlet at the top. It's a continuous, highly effective process that gets rid of unwanted grit. It's this obsession with purity that makes the final product premium grade. Chapter 4. The science of safety and separation. The fresh, desanded slurry looks pure, but it holds a natural secret that has to be dealt with: cyanogenic glucosides. Raw cassava contains compounds that can release hydrogen cyanide when the plant cells are ruptured. Now the varieties used here are sweet cassava, with low cyanide levels, but the risk is never zero. The wet processing method is exceptionally good at eliminating this threat. The grating process has already started breaking these compounds down. Now, the huge amount of water in the slurry will wash these water-soluble toxins away, making the final flour completely safe. This is a critical safety advantage of this modern method. The purified slurry is pumped into vast holding tanks equipped with large, slow-moving paddles that constantly stir the mixture. This does two things. First, it keeps the slurry homogeneous, so the starch doesn't just settle at the bottom. Second, it ensures all the starch particles stay suspended in the water, giving the toxins plenty of time to leach out. This stage is a quiet but critical pause in an otherwise frantic journey, ensuring the product is safe, pure, and consistent. Now, the next challenge is to get rid of all that water. Chapter 5. The Great Squeeze, Dewatering with Hydraulic Force. The cassava slurry is currently more liquid than solid. To turn it back into a solid mass, the factory uses a piece of heavy engineering that acts like a colossal mechanical fist, the plate and frame filter press. This machine is pure industrial power. It's a long series of massive vertical plates covered in fine-meshed filter cloths. At the start of a cycle, a powerful hydraulic ram clamps the entire stack together with incredible force, creating a series of sealed chambers. The cassava slurry is then pumped in at high pressure. The pressure forces the water through the filter cloths, leaving the solid starch and fiber behind. This expressed water, carrying the last traces of any toxins, is channeled away for treatment. As more slurry is pumped in, the solid material builds up into dense, solid layers. The hydraulic ram then retracts, the plates separate, and what's revealed is a series of large rectangular slabs of compacted, moist cassava known as wet cakes. They have the consistency of damp, crumbly cheese and are stark white. This single machine can slash the moisture content far more effectively than traditional methods, which is a game changer. It means there's significantly less water to evaporate in the final drying stage, which drastically reduces the time, energy, and cost of the whole operation. The wet cakes fall onto another conveyor, but they're too dense for the final step. They need to be broken down one more time. Chapter 6. Pre-drying pulverization. Those dense wet cakes from the filter press create a new problem. If you try to dry them as is, the outside would harden, trapping moisture in the center. It would be inefficient and lead to an unevenly dried, low-quality product. To fix this, the wet cakes are sent to a machine called a cake breaker or granulator. Inside, rotating hammers shatter the compacted cakes, breaking them down from large slabs into a fine, crumbly, wet powder that looks a bit like grated coconut. The science here is all about surface area. By pulverizing the cakes into tiny granules, the total surface area is increased exponentially. This means when the material enters the dryer, hot air can surround each tiny particle individually. Moisture can escape from all sides at once, rather than having to slowly migrate out of the middle of a big chunk. This step is crucial for making sure the next stage, the flash dryer, works perfectly. The wet, fluffy powder is now perfectly prepped for its final, fiery transformation. Chapter 7. The Inferno. The Art of Flash Drying. This is the technological climax of the whole process. We've arrived at the flash dryer, a colossal system where the damp cassava powder becomes fine, stable flour in just a few seconds. This is a masterclass in thermodynamics. It all starts with a powerful fan drawing huge volumes of air into a heat exchanger. Inside, a furnace heats the air to a precise temperature, but it does it indirectly. This is key because it means no soot or ash ever touches the flour, keeping it pure. This superheated, bone-dry air is then injected at high velocity into the bottom of a tall drying column. At that exact same moment, the moist cassava powder is fed into this turbulent stream of hot air. The instant the wet particles meet the hot air, the magic happens. The moisture on each tiny granule flashes into steam almost instantaneously. The whirlwind of air suspends the particles, carrying them upwards and ensuring nothing ever rests on a hot surface, which prevents scorching. The entire journey through this hot air column takes only a few seconds. But in that time, the moisture content is reduced from a damp powder down to a final, stable level of about 12%. This is the international standard for high-quality flour, guaranteeing a long shelf life. At the top of the system, the particles and the now cooler, humid air are swept into a large, cone-shaped chamber, a cyclone separator. The mixture is injected at an angle, creating a high-speed vortex. The solid flour particles, being much heavier, are thrown outwards by centrifugal force. They spiral down the walls and are collected at the bottom. The hot, humid air, now free of flour, spirals up the center and is exhausted from the top. The material emerging from the bottom of the cyclone is, for the first time, recognizable as flour. It's a fine, snow-white powder, warm to the touch and perfectly dry. Chapter 8. The final polish: sieving, quality control, and packaging. The journey has resulted in a mountain of pure white powder, but the factory's obsession with perfection isn't done yet. The flour needs a final finishing process to ensure it has a perfectly consistent particle size. From the cyclone, the warm flour is conveyed to a multi-layer sieving machine. It's basically a big box with a stack of vibrating screens, each with a finer mesh than the one above it. The vibration helps cool the flour and, more importantly, grades it. Flour of the perfect fineness falls through the screens and is collected. Any larger particles or clumps that somehow made it this far are unable to pass through. These coarser bits aren't wasted. They're sent back to a grinder to be broken down again and re-sieved. This closed-loop system ensures that almost 100% of the cassava that entered the factory becomes high-quality flour. The perfectly sieved, cooled, and uniform flour is now a finished product. It's conveyed one last time to the packaging hall, a clean, highly automated environment. Here, an automatic packing machine precisely weighs a set amount, say 25 or 50 kilograms, into a bag. The filled bag moves along a conveyor to be securely stitched shut. An inkjet printer automatically adds batch numbers and production dates for tracking. The sealed bags are then lifted and stacked by robotic palletizers onto wooden pallets in a precise, interlocking pattern. Once a pallet is fully loaded, often holding a ton of flour, it's wrapped in plastic film to secure the load. These completed pallets are then moved by forklift into a massive warehouse. Here, they are stacked in towering rows, a library of finished goods awaiting shipment. The scale is just breathtaking, thousands of bags of pure white flour that, just hours ago, were humble, muddy roots. So there you have it. From the thunderous arrival of trucks to the quiet, methodical stacking of pallets, it's an incredible journey. A raw, perishable root is washed, peeled, pulverized, pressed, and purified through a symphony of technology. This wet processing method, with its focus on purity and safety, delivers a product with vastly superior quality and consistency. This mega factory is more than just a production line. It's a testament to what's possible when agriculture meets modern engineering. The roar of the rasper and the magic of the flash dryer all work together to turn a staple crop into a valuable, global commodity that feeds millions and fuels the demand for gluten-free foods. The final bags of flour, loaded onto trucks and shipping containers, now begin the last leg of their journey. The cycle is complete. If you thought this journey through modern food production was fascinating, be sure to subscribe for more exclusive looks inside the world's most incredible factories. What part of this massive process blew you away the most? Was it the power of the hydraulic press or the sheer speed of the flash dryer? Let us know in the comments below. Thanks for watching.